Today, I want to introduce to you a new equation and a new numeric constant within the Phi series of numbers. Now, in my previous video, I described the 9 Phi series, which are seeded with numbers 1 through 9, and the Fibonacci series being Phi series 1. And many people are knowledgeable about this Phi series 1 or Fibonacci series, which mathematically describes spirals in natural spiral galaxies, sunflower seed spirals, or pine cone spirals, or the spirals in seashells. Now, mathematically, these spirals can be described with a simple pattern that where each number is the sum of the two previous numbers. So it's a micro pattern. If we look at the numbers in the Fibonacci series, or Phi series 1, the sequence goes something like this: 1, 1, 2, 3, 5, 8, 13, 21, and it just keeps going. So you can see that each number is the sum of the two previous numbers. So this is a micro pattern. Within the Phi series, there's also a macro scale that involves 24 numbers at a time. And what we can do is we can reduce numbers to a single digit. And what we find is that when we reduce it to a single digit, you'll have the 24 single-digit numbers keep repeating. For example, the sequence goes for Phi series 1, 1, 1, 2, 3, 5, 8, 13. So as soon as we hit beyond the number 9, or beyond a single digit, we want to reduce it back to a single digit. So the 13 becomes 1 plus 3 equals 4, and then the next number is 21. So 2 plus 1 is 3. The next number is 34. 3 plus 4 is 7. And we can keep doing this. What we find is that when we reduce these numbers to a single digit, the numbers 1 to 24 and 25 to 48 keep repeating. And so each set of 24 keeps repeating. So somehow 24 represents a complete cycle. And perhaps then 12 represents half a cycle. What I found is that this concept of a half cycle and a full cycle is very important in another macro pattern, very important to help define another equation, including a numeric constant. So why don't we get into it? Why don't I show you this new equation, this new mathematical constant, and let's go. Okay, here we have the Phi series 1, otherwise known as Fibonacci, and I've outlined 48 position values. So you can see the sequence goes 1, 1, 2, 3, 5, 8, and so on. So I've listed this all the way up to 48 positions. Now to look at the pattern of 24 repeating numbers, we need to reduce these to a single digit. So here we have 24 reduced numbers. So what I've done, I've taken each of the position values in the previous slide and I've reduced them to a single digit. For example, the 12th position is actually 144. And we can add the numbers 1 plus 4 plus 4 equals 9. So I've done this all the way up to 24 positions. And what you'll notice is that the position sequences 1 to 24 are identical to the sequences 25 to 48. And this would continue. So for example, 49 all the way up to 72 would be the same. Previously, I've mentioned this concept of a complete cycle being 24 and a half cycle being 12. So when I look at the 12th position value, 144, that really stood out for me. And so I decided to take a look at the 12th and 24th position. In this case, I divided the 24th position value, 46,368, by the 12th position value, 144, and it came out to 322 exactly. This really piqued my interest because whole numbers can be very rare in many of these instances. So 12 and 24 are 12 positions ahead. So I decided to take a look at the 11th and 23rd positions values. So 28,657 divided by 89 equaled 321 and some decimal places, 9887 and so on. not quite 322. So let me take a look at the 22nd and 10th position values. So 17,711 divided by 55, and in this case I got 322,0181. So somehow something was different. Something was different about the 12th and 24th position, or we can say that maybe something is missing. Something appears to me missing because somehow that 322 really stood out for me. My intuition informed me that that value was important. So if we held that constant as it is, so we held it as a constant on the right-hand side, what could we do to the left-hand side of these equations to make it equal 322? So when we divide 28,657 by 89, what could we add to that in some capacity to equal 322? So what I've done here, I've added a value to these positions at the 24th, 23rd, 22nd, 21st, and so on. All these position values, I've added a number to it, and keeping the lower position values constant, so the 144, 89, 55, and so on constant, I tried to make these equal 322. So 46,368 plus nothing divided by 144 is 322. 28,657 plus 1 divided by 89 is 322. 17,711 minus 1 divided by 55 equals 322. So you can see it's following a quite perfect Fibonacci pattern where we have this 0, 1, 1, 2, 3, 5, 8, irrespective of the positive and negative operator. In the previous slide, I demonstrated how we could add numbers to the position values. For example, around the 24th, 23rd, and 22nd, we could add values to that, and then we could divide it by the position values half an octave lower at the 12th, 11th, and 10th position to equal 322. So I just wanted to show you here in this slide where those values come from, the 0, 1, minus 1, 2, etc. come from. Now the Phi Series 1 or Fibonacci series typically starts at 1. So position 1 starts with 1 and goes 1, 1, 2, 3, and so on. But we can extend it backwards. So at position 0, it is a value of 0. But then at position minus 1, it is a value of 1. Position minus 2, it is a value of minus 1. So it oscillates between positive and negative numbers. So in the equation, 46,368 plus 0, that 0 is actually the 0th position value. So it just comes just prior to the 1. And when we do that, and when we divide it by the 12th position value, which is 144, it will equal that Phi Growth Scalar constant 322. Here I just wanted to give you another example of how this equation works. So in this particular example, we have again the position values below 1, so below that initial 1 starting value, going all the way back to from 0 to minus 11th position values. So in this case, I'm going to start at the 19th position value, which is 4,181, and I'm going to add the minus 5th position value, which is actually plus 5. Then I'm going to divide it by 13, which is the 7th position value. So the 19th plus the minus 5th position value divided by the 7th equals 322. So in this case, we're always going 12 positions ahead. So minus 5 to plus 7 is 12, 7 to 19 is 12, and then minus 5 to 19 is 24 positions. So that's a complete cycle. So one whole, a complete cycle, the three numbers within that will equate to this 322 Phi Growth Scalar constant. Let's now pick some position values for another example that are just in the middle. So we're going to pick the 17th, 29th, and 41st position values that are separated from one end to the other by 24 positions, and then within 17 to 29 and 29 to 41 by 12 position values. And we're going to plug these into the equation in the next slide. So let's formalize this equation or these series of equations into something that's a little more standardized. So here we have this Vn, or n in this case is the position value along the sequence. So we can take any position value and we can equate it to its a value 12 positions ahead times that 322 constant minus the value 24 positions ahead from what we're looking at. An example is I can look at Phi Series 1, otherwise known as Fibonacci series, and I can take the 17th value and I can plug that in. So the 17th value is 1,597. And if we go 12 positions ahead, it's 514,229, and we can multiply that by 322, and then we can subtract 24 positions ahead. So in this case, it's the 41st position. So 165,580,141, and when we do all that, we find that the left-hand side of the equation equals the right-hand side of the equation. So I refer to this as the Phi growth equation. So here's the formal equation again. Vn is equal to Vn plus 12 positions ahead times 322 minus the value at the n plus 24th position. So the Phi growth equation, it applies to all 9 Phi series, including the first one, which is the Fibonacci series, including the second one, which is the Lucas series, and then again the series 3 all the way to 9. So we can calculate any Phi series value by using the 12th and 24th position values, including the Phi growth scalar constant 322. So there you have it, the Phi growth scalar constant and the Phi growth equation. Now the equation describes the relationship between 3 numbers over scales of size. So for example, we can take a 1 number 12 positions ahead and 24 positions ahead and combine that with the 322 scalar constant, and we can derive any number in the Phi series 1 through 9, which includes the Fibonacci series. So this describes a macro pattern, new equation, a new scalar constant. Now stay tuned for my next video, which will be even more interesting. I know, more interesting than an equation. But it will describe some fundamental blueprints, actually, that underline all Phi series numbers. So stay tuned for that.